Greetings, I am Wesley Haun, agronomist with Tiger-Sul Products. I would like to share a few minutes with you today to impart some information concerning alfalfa, the queen of forages, and enhancing its production with sulfur nutrition. Alfalfa is a deep-rooted perennial legume plant. It's the forage leader in yield, protein, and total digestible nutrients. Alfalfa is the predominant forage produced in North America. It represents greater than 60% of all forage harvested in the United States. In Canada, cultivated forages are produced on 39% of the cropland, and alfalfa is the primary species. Some alfalfa principles of production I like to suggest is establish a uniform stand, produce for yield, harvest for quality, and market for profit. I do not have sufficient time today to address all four topics, so I will focus on produce for yield. To optimize yield, attention needs to be devoted to soil fertility, crop protection, and timely harvest. Now, research has documented that approximately 65% of yield potential can be attributed to soil fertility. So that will be the component I will focus on from this time forward. Alfalfa has high demand for several nutrients. For each ton of dry matter harvested, approximately 15 pounds per acre of phosphorus is removed from the field, 60 pounds of potassium is removed from the field, and about 7 pounds per acre of sulfate is required to meet yield potential. For an alfalfa crop yielding 5 tons per acre, phosphorus will be needed at 75 pounds per acre, potassium is 300 pounds per acre, and sulfate is 35 pounds per acre. And when we convert those pounds of nutrients to product that's applied, that would be 144 pounds of monoammonium phosphate, referred to as MAP. Potassium would be about 500 pounds of potash, and then the sulfate would equate to about 39 pounds of Tiger-90 sulfur. So these values are just for current production, does not include any soil buildup. So if production exceeds expectations, then the following year nutrient requirements should be adjusted accordingly. Now, these rates are too high for single application. Therefore, they need to be divided into 2 or more applications depending upon your management program. Sulfur deficiency symptoms and diagnosing those symptoms. The best approach is to take plant tissue samples, and when doing that, you need to collect the top 6 inches of the plant. That plant needs to be in the bud to 10% bloom growth stage, and you'll need to sample 30 to 40 plants per sample. When you send those to the lab, have those analyzed, and then when you receive the results, if the sulfate level is greater than 0.25%, then you have sufficient sulfur in the plant. If the nitrogen to sulfur ratio is greater than 10 to 1, then you probably have a sulfur deficiency and need further attention. Now, keep in mind that this nitrogen sulfur ratio is what's in the plant. It is not rate of application. This is strictly from a diagnostic standpoint of the amount of nitrogen and sulfur that's in the plant. It is not the application rate. Here again, obvious symptoms are not always present, and hidden hunger probably results in more yield loss than realized. And then the question arises, what is hidden hunger? Hidden hunger refers to a situation where a crop needs more of a given nutrient but has not displayed the deficiency symptoms. A plant with hidden hunger shows no obvious symptoms. The nutrient content within that plant is not low enough for that plant to develop deficiency symptoms and is not high enough for maximum yield potential. So graphically, the extreme left of this response curve has a very steep rise. It is within this zone that sulfur deficiency symptoms will be evident. The highlighted area is a region of potential sulfur deficiency with hidden hunger and yield loss. Note, this region extends almost to the point of the expected optimum nutrient uptake. Also, as part of diagnosing a sulfur deficiency, I also like to recommend soil sample analysis, collected at the same time you collect the plant tissue samples. A soil analysis utilized with a plant tissue analysis helps us understand what is totally available to the plant and what that plant is taking up. Sulfur deficiencies generally are most prevalent on ridge tops and side slopes. This is primarily due to soil erosion, less organic matter, and crop removal. The impact of sulfur nutrition can manifest itself in a symbiotic nitrogen relationship. Symbiotic nitrogen fixation is driven by rhizobia bacteria, which infect legume roots and form small structures called nodules. Within the nodules, the rhizobia bacteria convert atmospheric nitrogen to ammonium that the plants can utilize. Sulfur is critical in the nitrogen fixation process, and a deficiency results in less nodule formation, inhibition of nitrogen fixation, and a reduction of nodule metabolism. Now, in a sulfur deficient environment, there are less sulfur-containing amino acids which contribute to that reduction of nodule metabolism. Now that we appreciate the value of sulfur nutrition for alfalfa production, when and how do we apply Tiger-Sul products to alfalfa? In a new establishment, I suggest applying 100 pounds of sulfur per acre. That can be in the form of Tiger 90 or as Tiger XP. This will be enough sulfur to supply the needs for the first 2 years and possibly the third year or more. But I suggest in the spring of the third year, collect soil samples to monitor the soil sulfur levels. If additional sulfur is needed, then apply the sulfur with your phosphorus and potassium applications as well. If you have an established alfalfa stand, then we need to apply sulfur annually to meet crop uptake needs. Approximately 7 pounds of sulfur per ton per acre of harvested forage is needed for optimum alfalfa production. For example, 5 tons of harvested forage times 7 pounds of sulfur per ton equals 35 pounds of sulfur per acre. If you're using Tiger 90, which is a 90% product, that means we need 39 pounds of Tiger 90 to give us the 35 pounds of actual sulfur. Or if you're using Tiger XP, which is 85% sulfur, then we need to apply 42 pounds per acre of Tiger XP to give us the full 35 pounds of sulfur per acre. So in summary, alfalfa is an important animal ration component. It has a high nutrient demand, and sulfur is critical for plant metabolism as well as nitrogen fixation. Sufficient sulfur needs to be supplied based upon uptake requirements, that is 7 pounds of sulfur per acre per ton of harvested forage. So hopefully you have found this information to be beneficial. Should you need further information, you're encouraged to contact your account manager, or you can contact me directly via my email address as shown on the screen. So with that, I thank you and have a good day.